Welcome to our senior design project, tracking humans' respirations with a planar coil antenna. This is the block system diagram of our project, which includes signal generator, dual directional coupler, inductive coil antenna, DAC, and graphical user interface. Signal generator. This is the schematics that we use to design our signal generator. Here's a demonstration of the signal generator. Here we can see that we're successfully able to generate 4.38 MHz of signal with 1.07 volt peak-to-peak voltage. Dual directional coupler. Here we can see the dual directional coupler with the 1 input and 3 outputs. Here's the demonstrations of the dual directional coupler that we designed. Here we can see that the dual directional coupler has 1 input and 3 outputs. Those 3 outputs are VF, VR, and 1 to the antenna. Inductive coil antenna. Here's our coil panel antenna. In the right side of the corner, we can see that the test result data and the theoretical value. As we can see in the table, we are using this antenna for 14.4 MHz of signal. This is the demo for the graphical user interface. As we send the signal from the signal generator to the graphical user interface, we are successfully able to generate the signal and read the voltage difference between the 2 amplitudes. Here's the final demonstrations how the systems are integrated together. First, we're going to turn on the signal generator. Now, in the oscilloscope, we can see 1 forward signal and 1 reflected signal. These 2 signals are coming out of dual directional coupler, the reflected and forward signal, after it going and coming back from the antenna. Now here we can see, as we move our hand back and forth, we can see the change in amplitude of the forward and reflected signal. Now, using graphical user interface, we will analyze those signals. We can see the 2 signals. The first is forward signal and the second is reflected signal. In this graphical user interface front panel, the user can see the region loss value of the 2 signals as well as the linear displacement translated from the region loss value. Now, earlier we have seen that as we move our hand back and forth, we see the change in amplitude of the 2 signals. And here, this is what we are exactly doing. So as we change our amplitude back and forth of the 2 signals, we can see the change in the linear displacement. The red means it's more than 3 cm and the green means it's 0 displacement. This graphical user interface also provides us with a numerical value of the linear displacement up to 5 decimal points. And right above it, we can see the region loss value changes. And this linear displacement is directly derived from the return loss value, which is calculated by using a formula node on the control panel. And this is how we can track the human respirations using our design. Thank you for watching our demonstrations.